So we're gonna finish up these Stanley Meyer slides. We got Hope here in the background. We got Arlen Coakley's little flight thing, and got my phone charging there off of basically solar. Some little mercury bulbs back there, which is kind of cool. Yeah, I got these. There's another one. Oh, right here it is. Check out these little tilt switches. Isn't that so cool? I think it's cool. Alright. So basically, I was talking about how you have this trigger input energy open to the environment, and you decouple that with like impedance, like a light hitting a wall, and so you feed with drift velocity displacement current to displace charge, so the dipole can keep ringing, but you can actually pull some energy into a load, or it pulls itself or whatever. And the crystal lattice refraction drives these coherent waves like this, clapping together, and that makes electron pairs or Cooper pairs. And so I didn't show this at all last time, but if we're to go into here, these are my advanced stack alloy slides that I can post in the comment, but it's also in this presentation, so you can find it, which I'll be posting, or have already posted as well. And then, so you can see that this kind of is similar to Garrett Modell's research, but this is my own design, and this is open source, not able to be copyrighted. So this is for human development and progression. So here's a full stack material classification, so you can kind of go through here. We have a base conducting nickel layer, use all those pennies or whatever. You have a face-centered cubic structure, and this routes charge into the wireless Tesla coil transfer. Maybe you have bismuth, you know, it's the squares stacking on top of each other, which is a high permittivity conductor and enhances Casimir effect field stabilization. You might want silicon dioxide, for example, for an amorphous silica that acts like a dielectric energy modulation, and it enables vacuum fluctuations, like white water almost. And then you have a superconducting layer of yttrium, barium, copper oxide. So your copper oxide is your type P material, so it's got these electron holes, and this whole thing acts like a type 2 superconductor, so you don't have electron transport losses, so you enhance charge coherence, and you like separate the energy with that charge coherence using spin asymmetry from the Fe2 plus ion, which induces a word force charge separation, and it's acting like a resonant quantum layer and a dielectric simultaneously if you have FeS2 doped with quartz, you know. So basically 91% quartz, maybe 9% FeS2, for example. Excuse me. And then you'd have like a surface coating of something like Al2O3, which will be always forming on the positive side in the presence of the atmosphere, and it acts like a dielectric insulator and basically enhances your surface charge accumulation in the underlying layers. And we're really playing with the energy band gaps here, going through here, and you can go here on your own time But basically this just goes into like cost and bill of materials and how you would do it. So yeah, back to the Stanley Meyer stuff, right? Because this is where we're at, where our focus is on continuing these slides. I know I'm kind of occupying a lot of time leading into this, but I just want everyone to be on the same page a little bit. And so the four types of magnetism: paramagnetic, diamagnetic, ferromagnetic, and antiferromagnetic. So we see with paramagnetic, it's basically has to do with the orbital structure of the baryonic matter in itself. So it has to do with ionization, right? So you can see that it, like this has an up and an up over here in this p orbital, and you have these unpaired electrons. It wants to form a Cooper pair, a yin and a yang, and so it's attracted to a magnetic field, because a magnetic field is a cross product of two E fields, which is driven by a scalar potential wave, which is like this, either standing waves or these like compression ether waves that are interfering in a superposition pattern. But the point is here's some examples of a paramagnetic material: oxygen, sodium, aluminum. So there's like these magnetic field lines that are bending around my body, right? I'm like this paramagnetic thing almost, and like I'm attracted to the earth, right? So the diamagnetic is where that p orbital now is filled up and those Cooper pairs are satiated, let's say. And so what that means is now you have conductive materials, because if this is full and you have excess electrons flowing in that crystal lattice structure, it can almost act like the 90 degrees phase limit of a cyclotron through the crystal lattice, and so you get the sea of electron effect that they teach you in chemistry. Oh, it's just a sea of electrons. Well, why? And they're like, I don't know. Well, that's why. Okay, so the ferromagnetic material, it's a bit different in the state now. We're stacking the atoms and we're viewing it in a more macroscopic perspective of scale. So it's not just one atom anymore, it's the collective. Sweating. So the positive goes one way, the negative goes the other. One is like state 1, the other is like state 2. It's got this binary state, right? So the Fe2 plus ion is responsible for the quantum spin asymmetry, is what it's called, if you wanted to know, for iron. You know, because a lot of magnets are made out of iron and whatnot. There's my cat. I don't know how that got moved. Is that better? You can see my kitten a little bit. Just freaking adorable. Okay, sorry about that. Mass of the electron goes down. Mass of the electron goes up. Ferromagnetic, it's like a slingshot, right? And antiferromagnetic, it's like got these horizontal lines so that when you have an electrical bias, it aggregates the electron spin. And that's just the angular momentum of the curl of the ether. And that builds voltage across a standing wave, because the upspin and the downspin, it's like building potential energy like this. And so you have a capacitor, it's limited by these frequencies. It's got all these frequencies out here. It wants to come together, and the more you come out, the more frequencies it can access over here. You know, it's farther away, so it's not going to pull as hard because there's more frequencies inside of it compared to outside out here. So it doesn't want to come together as much, but the potential energy is bigger, right? Okay. So this is where it gets interesting. So we have an altermagnetic Fe3+ and a ferromagnetic Fe2+. So this is like a magnet. It's like driving a slingshot. So each water molecule, going back up to the water molecule, it's like a slingshot. The negative can get slingshotted through. Or, and it's like the ether wants to flow one way, in my opinion. I guess if I were to match this, right, it'd be like flip 180, boom. Right? Now this looks like this. See that? Okay. And any NP junction is going to act like a thermoelectric generator. I don't know why I can't click on my screen sometimes. Okay, going back to this slide if it'll let me. Why is it not cooperating? There we go. I'm not done on this slide. Driven from existing Earth's magnetic fields. So the rigidity of something is affected by its this ligand is basically at the end of this right here. Ligand, so above as below, Marcus theory, sub H vibrations potentially stacking, in my opinion, but beyond that point, in this limited framework, we have a foreground state recovery, delta G naught, in smaller in magnitude than its reorganization energy. You can get energy from the environment, leading to a condition in the ligand field strength with an increased rate of excited state relaxation. This point where delta G, your Gibbs free energy is equal to your wavelength or whatever, or maybe your band gap, is the barrierless region. It's where the activation energy of the process in question disappears and the rate of reaction is dictated solely by the electronic coupling between the two states. So if something is at the 90-degree phase limit in cyclotron resonance as a Bose-Einstein condensate, and you know that band gap, or you know that plasma state because of its color, you know its wavelength, and it's one of those things that it's the Ligand field strength builds in more potent excited state power while simultaneously increasing excited state lifetimes. That's an amazing statement. This isn't from me, this is from the source you can check out if you want to. So going back to this slide, we have basically these non-conjugated, more flexible ligands and rigid ligands. So this is rigid because it's like a slingshot with momentum. If you have a wheel spinning in your hands, it's rigid, isn't it? And if it's not spinning in your hands, it's not rigid. It's really that simple. And I know all these words sound confusing, but I'm using the words that science uses because I need to communicate with humans somehow. Because it feels like really hard to. So it's like the water nodes or the scalar wave collapse nodes into current with the magnetic field itself. If you burn a wire, collapse a scalar wave through a wire, if it doesn't vaporize the wire, it vaporizes the material, the insulator around the wire at these nodes, just like this magnetic field. Like this solar wind is hitting it, like the scalar wave is collapsing, and these are the magnetic field lines. It literally does the same thing. Okay? And so when you look at the Fe2 plus and its photoluminescent Fe3 plus complex with a higher phi, you see that it's really this altermagnet driving spin aggregation entangled across time in combination with going back to a state that's a slingshot drive. And so you get a drift velocity. And this all is really driven by Earth's magnetic fields, because when you have a uniform magnetic field, from our perspective, differentiate the curve, we're tiny, then basically you see every charge oscillate. What is a charge if not for a dipole? Dielectric field. Not just electric, the Tom Bearden waterfall. So we've been led astray by science. I've been intentionally misled by paying $250,000 into my education, and I'm fed up and I'm calling bullshit. And I do not want you to go to college. I want you to teach yourself, and I want you to become an experimentalist, because you will find that the universe will not lie to you. But people will. People definitely will. They'll take advantage of you to make you a slave and use you as a tool. That's been my experience in life. So I'm here to be like, Stanley Meyer was not a fraud, and if you understand chemistry, buckle up and be ready to have a voice, because if you're not and you're compliant and you're complacent, you're part of the problem. So, spark, nonlinear junction, infrared light, atmosphere, interact, and kickstart a bipyrrhid ligand, for example. And that ligand field strength can be altered in its rigidity with the flux of the motor being an electromagnetic generator with the engine block itself. So the cylinder walls and the atmosphere interact. This is the part they didn't want you to know in my live stream that they cut out. They didn't want Ryan Cerny, who has way better chemistry knowledge than me, to see and interact with this. This guy, Ryan Cerny, he's got a master's. He's got way more education than me. He knows chemistry better than I do. He frickin' teaches it, okay? I wanted him to see this and react on live. But no. No, they don't want that. Okay, so note the peak emission from the sun is green in intensity, and consider the doubly ionized oxygen gas is green, and it's coming from water. You know, the oxygen, the negative part, the grounded part, the part that hits the cuprous oxide maybe, a nonlinear junction like a negative resistor that is basically forcing a bunch of current through it because it already has voltage. You see, the water creating a water hammer effect can create hundreds of volts. And I show that earlier in my slides. If you go back in this live stream, we see this structured water effect building potential interfering n equals 2 with the basically the UV light, and the n equals 3, the infrared light, and right in between there is a visible green light, which is kind of like this Marcus theory oscillator right in between n equals 2 and n equals 3 of the protium being ripped off of the water, which is really just this fancy name of calling it pH, or the acid component, or that sometimes even becomes part of the hydronium component, which becomes a part of this weird different forms of asymmetrical stretch. And consider that this word liberations is right under this mode of vibration and this mode of vibration simultaneously stacked on top of each other. Nothing is an accident. All of this is intentional. You were misled by a design, and I am here to tell you the truth. There is no topological monopoles ever. It's only depending on how you slice up space and time and how it's flowing, depending on your perspective. If you think it's a topological monopole and you zoom out enough, you'll find that it's not. Okay, Stanley Meyer, this guy is dead, and he is not a fraud. I have a college education, and it's worth nothing. Don't go to college, kids. This Bohr model, this is not really it. 4D sub 0. Stack 3 of these on top of each other. cobalt, the center oscillator of the periodic table. Your engine block is made out of iron and nickel. Silicon dioxide is your crust. Your atmosphere is diatomic nitrogen. Right next to oxygen, CO2 in the atmosphere, all stacked on top of each other. Oh, no, boron. Boron. Yes, a semiconductor right in the same row. And if you know chemistry and you know of boric reactions, then you're picking up what I'm laying down. But if you don't, then you probably don't. That's okay, because you're going to pick up on a lot of patterns. Because we are pattern recognition machines, and we are spoon-fed patterns from the internet AI. The internet is AI. It was always AI. Did you know that? You have a curated search result just for you, based off of your belief system. Yep. So, I'm here to expand that by giving you more sources so that you can restructure the algorithm on your own. Okay, you can consume different products. We have power as a consumer, and we can come together and we can build technology, and you can have a voice, and you can spread this with people you know. So you have Fe, high spin, interacting with the atmosphere, and we see its coupling to the photonic plasma of the sun, whether it's touching the green light or not, because the etheric pressure of the photons, the solar wind of the ether, is there regardless. Did you know that? Did you look up sidereal radiation 1920 article? Just look it up if you don't believe me. So cobalt, center of the D block of the oscillator. Oxygen, magnetic. Nitrogen, and then carbon. See how it's like stepping up into the oscillator? And then you have the protium on the outside. And the protium is a pure positive and negative, right? So you have cobalt, fuel, light, and air. And your fuel can be water. So this is how NASA makes water for astronauts. Did you know that? They use light and acid and the atmosphere or gases floating around. That makes water. So we can make water out of the atmosphere to make people live in places they couldn't, but they wouldn't want that. They want to put you in a city to control you so you can't grow your food, so you're reliant on a system. You know, this is bigger than just burning water. You gotta see it for what it really is. So you controlled a light relay through a photoactive chemical reaction. It's a controlled relay under visible light, driven by the photonic pressure of the sun, whether the sun is there or not, because you got a spark gap. You got a multi-frequency oscillator in there that's already timed with the ignition. And guess what? The heavier diatomic nitrogen in these things slow the wavefront of the hydrogen. And it's not just a hydrogen wavefront of combustion, it's the steam. But it's not just the steam, because you can actually take advantage of the work of some of the protium in itself. And that's why they don't want this out there. They're scared. They're scared. You know what? I'm not scared. I'm not scared of them. And they want me to be. And this is bigger than me. You have water in, you have water out. You have salt as a byproduct. He said it could run on salt. Now you see why. Because the salt just flushes out, right out of the exhaust. You see? The nitrogen is a part of the chemistry now, making it active. Not just a passive thing, while simultaneously slowing the flame front. Any carbon dioxide or whatever, you know, in these R groups, maybe some of the carbon dioxide remains inert and just flows right through, you know? But you get these amino radicals, potentially. You get the extra hydrogen coming off and forming these sets for the residual ones, so it's like self-adjusting. You have a this isn't directly related necessarily, but I just want to note, like, MRI machines use zirconium wire for a reason, you know, interacting with the neutrinos. And yeah, so going back to the engine block and the atmosphere and the hydrogen interacting, we see H2N with a hydroxide group. Oh, that can be formed by the water and atmosphere. You form these things. Maybe you form like a carbon chain ring from the excess CO2 there. Maybe you form some water out of the exhaust. But, you know, maybe your engine block is forming like a nitrine transfer cylinder thing, you know? And nitrine can be functionalized to make graphene, you know? So like maybe whatever like hydrocarbons get in there don't even like mess with it too bad, you know? Because the graphene is like a superconducting layer that can be ripped apart and recombined. And like the copper, for example, does the same thing as like a cobalt, pretty much. So I'm saying like maybe we can get away with using some pretty cheap materials like copper if we have a water hammer effect into a pulse DC system of like a little copper ball plated in like titanium dioxide to get it stiff enough. Maybe it's like a ballpoint pen, you know, like feeding out so that like the pressure of the cylinder allows the fluid to go through and then it flows around the cylinder and it oscillates, you know? And maybe that cylinder is like made out of aluminum with the right geometry to create like a little infrared UV laser, because like the UV is a part of the aluminum, but the infrared is like a part of the N=3 of the protium being ripped off the water as it's making ionized water of hydronium. And so that's like interacting with the nonlinear junction around the ball. Maybe it's cobalt, whatever, you know, probably cobalt would work better. But I just want to pull this slide up again and note the interference pattern of light depending on its energy levels going through here. And we literally see this square in this circle, in the circle. And we see that if we follow these lines that form this like form of a oscillator, forms these same sort of nodes, right? So you can almost like imagine it. I guess if I were to tilt this back to here, you can kind of see, if I was to start here, be like, choo, 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 choo. So yeah, square, circle, square the circle, square, square, circles, 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 base 1, stacking, okay, stacking, stacking. Oh yeah, speaking of stacking, right, don't forget the stacking, the stacking, the stacking, and the stacking. Okay. So this was kind of the couple pages I was trying to show on my little notes discussion page, and who knows if this is right, if this is wrong, but I thought this was interesting. It's interesting to derive what drives a thunderstorm generator just from thinking of light and electrostatic potential. And thinking of that as a liquid crystal solidifying into grains, the phase transition represents a creation or solidification of reality that one is aware of. By using rotation, electrostatic potential, and frequency, power can be applied to mankind. You see, basically what this is your coulombs, your voltage, and your radius, and that's like power, you know, your voltage, and your centripetal acceleration. That's really all it is. And this is kind of like this torsion field that Tom Bearden alludes to. And there's a torsion field in here, and there's a torsion field in here, and in here, and in here, and in here, and in here. More torsion fields. Not just torsion, of course, but we should be thinking of torsion instead of just what, you know, Einstein and Oliver Heaviside and all those guys let us down. Like, there's no torsion in your model. So, exotic vacuum object is EVO. Kind of interesting EVOs here. This is going up. This was going up, and now it's going around from the negative to the positive, from these two through and on to here. So what you see is likely just this big bang, but sometimes at the right timing you can capture something that you wouldn't normally capture. Alright, smash that algorithm. Like and sub. And next video is going to be going into this a little bit, and maybe some ideas on how we would accomplish this Stanley Meyer stuff.